to share the screen. How about this? Does this work?
Good. Yes, work.
Okay. So can I start now?
Sure. Yeah,
Okay,
please.
okay. Okay, let me just start. Hello everyone, I'm Lingfeng Zhang, and I'm very happy to be here and to talk about AI for science and scientists with all the speakers. And I think I will just separate my talk into two parts. One is AI for science, and the other one is like scientists. And maybe a bit before this, what I want to share is that, uh, in my view, and also my personal experience on AI for science, is actually separated into several stages. So when I graduated from Peking University, that was the year 2016, and I went to Princeton. And also around that period of time, the boom of AI just began. And and in particular in that year, the biggest news was AlphaFold, AlphaGo, in which the DeepMind uses deep reinforcement learning to win the Go game and win the world championship. And also, it was also that time we started under the advice of Professor Weinan and Roberto Carr. We started to think about how to apply AI in more interesting problems in science, not only like Go games. And what we found was that in science, on one hand, actually there's no such places like ImageNet or AlphaGo. One have very clear like problem setup so that one can just directly develop the model. But on the other hand, what AI truly gave us was that it gave us deep neural networks and the capability to address the so-called curse of dimensionality problem. So in the first stage, what we did was that we use AI to solve a few set of scientific problems and to solve like physical equations more efficiently and to discover more things based on this new set of technology. That was just the beginning. But definitely the story of AI has jumped from ImageNet and AlphaGo to ChatGPT and what we can see right now. So then actually after that, what I found it was that in the last 5 years, AI for science was also going through a stage that one need to just build up the infrastructures for like future scientific discovery. So the first part of AI for science will start by what I would like to just show according to this rationale. So what we need to do and the possibilities, uh, uh, the things that we can consider applying AI to address is really just a lot. But what fundamentally in science that we need to think about and what AI can really help, uh, then actually serves the beginning of our second round of exploration. So the general picture is that the following. So science before AI for science, actually it's a very large topic, but definitely there are two kinds of so-called science. One is more pure science, for more pure discoveries and in the freestyle, but also there's a lot of like expectations on scientific discovery and research, in which we actually invest a lot of money to expect a bit more like scientific discoveries. So, and the major bottleneck and the dilemma is that the massive investment will typically result in very limited output. The reason simply because that we have very large um, space for discoveries, but we only have like, even though we invest a lot, the rate and also the scale of discovery can be very limited. So this is the general picture. And one vivid example is, I think, happens in most chemistry labs. So why this gap? The scientific progress is constrained by the limits of the human brain and traditional tools. So in this case, one is unable to keep pace with the scale of what is possible. So this is chemistry lab, like 200 years ago, and this is a picture by Professor Zhu Rong. And even like after 200 years, the typical architecture and all these equipments are very much the same. But definitely we have more advanced instruments, but basically the methodology behind is so-called trial and error and cooking style methodology. So this is what typically happens in like a huge number of labs. And then how AI for science tackles this. So in one sentence, I would say like what one could consider after the period and years of like AlphaFold and this type of like particular um, particularly ready problems. What we need to do, we could consider is actually to revolutionize that's every step of scientific R&D and form closed loops for quadratic acceleration. So there are three different types that scientists every day is actually doing: reading, computing, and experiments. So traditionally, there are traditional ways, definitely. And in terms of for reading, there are massive literature volume but 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 it's more and more. And I think right now every year we have like nearly 10 million number of papers published, and it's more and more information in terms of a very fragmented form. And actually, this is the beginning, and definitely in combination with AI and after a very massive dirty works, what we can do is we make all this data AI ready. This is what I will just introduce later, and the second part is like compute. Previously, what one can consider is like we use a limited number of tools and principles to do computations or to do analysis. And right now, what we could consider is a bunch of AI-based general purpose models as well as like special purpose tools. And also previously for experiments, very expensive and also very labor intensive. And what we could consider when what's actually is happening is that there are more and more automated and intelligent wet labs. And this is what is happening. And what our vision of AI for science is that this is all these technical factors for AI for science. As long as we could just scale them up in the sense that just like for AI models, it's actually three factors: compute, data, and model that are scaling up. So what we could consider is that as long as we can just put all these technical factors together and effectively scale them up, we will just have a different paradigm for research and then for science. So this is what we have been doing. And then actually, as long as we can just make them a closed loop. Previously, a closed loop process can be made automatic, and that just makes the discovery process faster or more um, organized. But what AI can help is that as we form closed loops, it can further just learn data from these closed loops. So after each loop, the model get better, and in the next loop, the model can perform better. So this is a rough idea of how this this ecosystem will change after we have all these different factors scaled up and also become a platform. So this is general idea. So then how we did this? So this is what happened in the past like 5 years. I will primarily just talk about what we did, but actually I would stress that this is actually happening in the whole community, and I truly feel that this year is the turning point. So what happened? So in terms of reading, so what we did was so-called like Science Navigator, and this is actually a slide I prepared for audience in Abu Dhabi. Actually, so actually this is a video from YouTube, and this is actually in Arabic.
زي ما انتم شايفين بيبحث في ال 160 مليون
So that
كلمة اهو.
actually, so
يبدأ يبحث
what
السؤال
what the,
الذي يعمل البحث.
what this tool can do, and I think there's already a large number of users on this platform and more than 1 million. So basically, one can ask like question, and after like after a very short time, the platform, it will just give you an answer, but also with all these papers, the references properly attached to the answer. So this is a different factor. So I will just show maybe this question here. So what was the progress in the field of solid state battery over the past week? So what it can do is like it start searching, and also it can just give an answer very properly ranked and considered. And also there are figures and all these type of summaries involved. So what actually is what's behind this, given this kind of like capability, is that let me just show you later all this performance, and I think we can just ask the questions after in the Q&A or just discussion part. But what I would like to mention and stress here is that it's really like systematic process that we adopted to build this final solution. So actually what we need to consider from the point of view of AI and data is that what are the like ultimate source of scientific data? There are three types, like from literature or from computation or from experiments. So there are raw data and source data, and one need to just go through a long process to make them AI ready. So after making them AI ready, they can be used to train the next generation AI model, and they can be used to serve as database so that we can just use or just get answer by referencing the database. So this is what we one need to do to make this kind of like platform. So then in slightly in detail, what one need to do is that starting from the data sources, one need to just wrap them up, and in the processing part, what I would like to say is that in all these steps, even though we already have like general purpose models or these large models that is becoming more and more capable, in many cases, in scientific literature or in general scientific data sets, one need to address a far more range of complicated cases, like this different form of molecules, and also this tables and images or spectrum data from like some characterization process. So what one need to do is that one need this a model to just properly understand what's in the scientific content in the paper, and then extract them out so that one can just properly properly read or properly understand what's in the data. So actually this is on one hand, actually, if we look at the large models, like the top models, they are becoming stronger and stronger. But in many cases, in particular for like molecules or for spectrum data, and in all these cases, they're still like far from a very professional level. So then what one need to do is essentially like just like what one did for like the data from the internet, so that one needs an annotation system to build up the loop so that the human or expert and also the model and also the eval and data system can form a flywheel of data, so that one just process more and more data and get the model better and better, and then finally just make all this data AI ready. And also then also one just through this process, one can just make some further, make this new data make an automated pipeline to address new data. So this is what's essentially needed to build up the system. And then after this, what one can consider is that one just extract different types of data, like Polymer database, battery database, and instrument database, and all Scholar database. This is the basis for our next topic, AI for scientists. But basically, after all this whole process, one just make the previously very messy and a large amount of fragmented data into AI-ready data sets. And it's only after that one can consider like a very general purpose AI agent that is not only just a demo for a specific field, but for the whole range of scientific discovery and literature. So then actually what I just mentioned, on one hand, serve as like basis for a product that every scientist can use. And on the other hand, it actually can serve as a database for the next generation AI model. So basically, this is the reading part. So reading part is essentially the data part, and data is crucial for not only human, but also for AI. But it was a very interactive human and model and AI system interactive process that is needed to finally just construct the whole system. So this is what I want to share for the part reading. And after all this process, after having this so-called science navigator, now what one can consider is then just like to quickly get a feeling and also get to know everything about every topic in a very new way. So this is reading, and then the next is compute. And this is really a long story, and I don't think I can just cover like the essential part very easily, but I will just quickly just go through what we did. And there are like one point I would like to mention here is that since now everyone have a feeling of like large language model and also modalities for like images and all these different modalities. And what I want to show here is that in science we also have like a large range of different modalities in terms of like three-dimensional structures or like proteins or large molecules in terms of sequences. And so it's input and output that defines the model's like modality and model's capability. And in all these different AI for science models, we need to just address each specific modality. And definitely this is what happened in the past like several years. And also in terms of compute, to generate data set and to train these models, and also to perform simulations and also to provide services, one needs very different, very specific computing systems that are like not very similar to traditional high performance computing systems, nor like just cloud native like these cloud systems. So it has like different types of need for different capabilities. For example, here, like this is ERMIT is our like platform for drug discovery, and I will not go into these details of what it can do. But what I want to stress here is that for different functions, like Unifold is like a AlphaFold is a protein structure prediction tool, and Reinforced Dynamics is a simulation tool, and that is like very high performance and enhanced sampling simulation of protein structures. And UniDoc is a solution that is made ultra high throughput. So actually this make one can just process like 100 million drugs very easily, drug candidates using this tool. But all these computational patterns and need for the computing system are very different. So essentially, what makes them different from demo to like production level tools are these infra level computational capabilities. So then what I I would like to stress here is that there are different types of like AI for science computation. So previously we have like scientific computing simulations and also at industry level. That is like doing like typically solving physical equations. And then we have like AI model training and AI inferences and also combined versions like just like I think also what Professor Dongbin did a lot, like solving PDEs, and uh, we address model and data and also these computational patterns in a very different and diverse way. So then if we want this to happen like at scale, then the underlying computing system will need to be also large scale and also high performance and very versatile in terms of supporting all these different compute. So then actually what we did behind all these capabilities is the like elastic scheduling and also high performance optimization system to support all these different types of compute. And also this serve as infra for like compute. So this is the second part. And the last part is experiments. So what we realized, like just like what's happening right now in the field of AI, ultimately to make real impact and to make to change the world, the AI model needs to just interact with the physical world. And also in AI for science, in a lot of applications, one can just read all this paper, existing knowledge, and one could just design a lot of like different materials or drugs for just using all these possible tools. But what differentiate like the further impact is that one can make what's designed or not. Just for example, we in the past several years we had a lot of experiences. We already developed all these tools, readings for reading and computing, and but still like design molecule after designing, we can only just wait for like more than 1 year. We're in close to 2 year to synthesis the molecule. And if the molecule cannot be synthesized, then actually all this effort will be like wasted. So basically, experiment part then becomes the bottleneck of the whole closed loop system. So how we address this? So after just there's actually a lot of effort in this direction, but what we just realized was that it's not like GPUs, CPUs, the computing systems, where it's not like the the electric vehicles. And actually, it's very similar to all these edge computing systems. So there's a lot of like different equipment, and for all of that, for each specific processes, one have all these different components. And if to make the whole system automatic and also intelligent, one actually need a system to connect all these different parts and drive them more effectively. So all these different part could become bottleneck if one part is just stuck there. So then actually one need to just go through all these different processes for each specific case, the preparation and synthesis, as well as characterization and testing, and to consider like bottleneck and to just do the connection and automation processes. And then it's because of these experiences, what in the very beginning we actually considered AI as a tool for them to better see the world, to better do a reverse problem, to better like address characterization or just modeling problems. But later, what we found, it's very important to develop operating system to connect all these different parts so that the system can just run more effectively. And what we did was that we developed so-called Unilab operating system. And right now it can already just get connected to like hundreds of different hardware parts. And then for different purposes like synthetic biology or energy materials, and for different labs, one can just use this system to connect all these different um, equipment and then form a closed loop. And then on top of that, all these reading tools and computing tools and experiment tools can be put together for like research purpose. So this is what we are doing right now. And definitely it's not down just like the reading part. We already covered all existing, most papers, but here we are still like working hard to connect more like equipment. But in my view, like the ultimately, if we could just get all these things connected and optimized in a way that is AI native and AI ready, then we can see a very different future. Okay, so this is what I just would like to just introduce for the AI for science part. So in the past 5 years, I think my real feeling is that um, it's very easy to, or very straightforward to find a good problem to solve in the very beginning, just like AlphaFold or deep potential, what we just did. But later on, actually, we as we truly believe this will cause a paradigm shift, one really need to do a lot of like um, engineering effort and like construction of the infra for the next steps. So it's very similar to what happened like before this boom of AGI and ChatGPT. So then what's happening right now? So what my strong feeling is that right now AI for Science is just meeting AGI. So actually the two trend is coming together. So OpenAI imagines our AI future as like 5 levels. In the very beginning, this is the end of 2022. It's like chatbots, and ChatGPT is the best example. And then the next level was reasoners, and after one can just mimic the conversational language, it can just start to just solve human level problems. And the reasoning and definitely DeepSeek is like a very good candidate in that like top reasoners. And the third level, and also what's very hot right now in AGI is in the field of like the general AI is like agents. So right now we are witnessing like a large boom of like development of agents. It's level 3. And definitely this stage is not done yet. And still like there's a lot of like things to be built and also to be iterated in terms of like the infra part and also product part, but it's actually just happening very quickly. But after that, and also starting from this level, what's mentioned and also the general trend in general purpose AI is that all this large, massive set of data on the internet already taken or already like absorbed in an AI model. So then data is the engine for AI model evolution. So then where's the additional set of data? And also, if we want to make the AI system more and more capable, just to reach level 4 innovators, definitely if an AI can aid in invention, actually scientific discovery is one of the most important form of invention or discovery in human intelligent activities. So then actually, in terms of functions, AI for Science will meet AGI. And also in terms of the problems that need to be addressed, uh, for example, the perception level, multimodal models, they need to just be capable of like reading scientific literature and understanding and reasoning like a scientist. So actually all this part, if one wants an innovator to really just do scientific discoveries, one need to address all these problems or all this infrastructure build up problems as just what I just mentioned. So it's really like this stage that will be very interesting for both AI and AGI. So also on top of this, what we are right now doing that this is SciMaster actually a product we just launched in collaboration with Shanghai Jiao Tong University and also Advanced Algorithm Institute in Shanghai. So basically, the general idea is that we put all this infra part together to make this agent a very general purpose one, and also then we actually make all these open source solutions, all these tools that we were the ecosystem developed agent ready. So make them a very automatic system to make them all MCP ready, and then make them all connected. So this is what one can do on SciMaster. So what's different from like what I just introduced, the Science Navigator, is actually it can just use all type of tools to make plans, and this is to run all the jobs concurrently, and also even to use a lot of like computational tools to reach results. And this is what it can do for surveys, and it can also do a lot of other things. And maybe I could show you later. But basically, okay. What I would like to stress is actually this is happening very quickly. So we're reaching like on bottom what we're reaching are these are feedbacks from different places. But what I would just show is like this this conceptual figure that what we did was that reading computational experiment there, all these things that one did, and finally in terms of models were software, and they are actually then seen as tools. And all these tools can be made agent ready by making all these interfaces ready for agents, and actually the protocol is right now already reaching a consensus. This is MCP, and after all this, one can just make their own agents, where all these different agents can call these tools. This seems to be an ecosystem that the whole scientific community is heading towards. And on the other hand, since all these agents is now conducting research or writing papers even better than in some sense mediocre scientists, then actually this is also a large pressure on the scientific community. So then what I would like to summarize here is that the infra part is really something like we build, and we feel very important, and it's right now at a different level. And then agents and also future innovators is this AGI is heading toward, and also AI for science is like is heading toward. So I think this is like where we stand right now. So then on top of this, and the interesting part is like this field is still like evolving pretty dramatically, and also in a very nonlinear fashion. So what will happen for scientists? So this is the interesting part, and I will just simply just show what we did recently. And definitely, okay, I already covered. So definitely in this web page, one can ask a lot of different kind of problems, and one definitely can just ask questions about scientists. And for each scientist, and besides like conducting research on the platform, actually they also need to just promote and to showcase and to get connections with each other on this platform. So it was in the beginning, it was like the process of connecting or of like collecting and also processing all these papers that we put all this information of scientists and scholars on the together. And also then we would, I think it's then I think last time when I was on the ICANX activity, we I think we came up with very good ideas on ICANX, which is just to 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 see like the global impact of all these ICANX speakers. So what we made was that let me just use my profile as an example. So when I search, like for example, my name, um, and we'll find this, and we also have like this link phone in Shanghai Jiao Tong University, and actually we just had a discussion before this talk, and this is still under testing, but I think it's very interesting. After collecting all this profile, one can just see the global impact, and I think everyone will be like very much surprised by like a lot of like impact or a lot of like connections like previously unseen. For example, here I think just before this talk, this is my global impact map, and this is Professor Dong Bing, and what's very interesting is like there are like citations or collaborations were from very different places. Like here is in Africa, and I just had a look at the paper, and I think it's a survey paper by uh, these brothers in Africa, which cites Professor Dongbing's uh, work. So this is a very preliminary test, but we found it's very just rich, and there are like a lot of different possibilities. For example, this is like the connections and academic tree of Professor Dongbing, and Professor Shen Zuo is on a very special place. This is a supervisor, Stanley Osher, and we all know him, and those collaborators and students. And it could be different, but the author can just edit this and also to further improve this. And it's because like we have all this, and I actually also searched Xiaonan and uh, Professor Hai Jiazhang, and actually this is also all this the speakers today are, I think, have a very wide range of impact on the whole world. And also basically with this, one can also make agents that represent the work of a specific author according to um, his or her publication, and also make connections to each other. And once one come up with an idea and need collaborators, maybe this could be a new way to find collaborators and also to promote further scientific discoveries. So this is the second part for authors, and it was the infra that supports and made this possible, but still we are improving this. So I think this is also a joint work with the ICANN Act platform, and I think we could just chat more to just uh, make it better. But overall, I think all this technology and um, the underlying infrastructure is making all these things happen possible. So we are right now standing at a very special place, and I think it's very crucial for each discussion to define the future of AI for science and scientists, because I truly believe that next year AGI will go to the next stage, innovators, and the whole scientific community will like face a challenge or stand at the point that to answer this question where we are heading toward. So I think this is the practices and current things that we did. And maybe let me just stop here, and maybe we just, for further questions or interesting discoveries, let's just wait for the questions of Alex. Okay.
Okay, great. Hi, Linfeng. Can you hear me? Yeah, am I clear
Yes,
now?
yes. Yeah.
Okay, that's so nice. I love this page. Okay, please stop here. Yeah. So, Dongbin, are you here? Yeah, can you hear